Hi, good day and hello everyone. My name is Reba, or you can call me Arya. I am a final year computer science student at University Science Malaysia. My matric number is 154439, and today I'll be showcasing or introduce you to my final year project, which is an AI-based multi-camera markerless motion capture with joints angle and Reba calculation features. Let's go. Motion capture technology has assumed growing significance across various fields, including computer animation, engineering, even sports science. And owing to its capability to track and predict human movement as naturally as possible, markerless motion capture system has emerged as a popular, low-cost alternative compared to the conventional method using tools, markers, and even bodysuit, etc., etc. And as a way for many people to experience motion capture. Notwithstanding its limitations, markerless motion capture has found numerous applications, particularly in the domains of sports science and healthcare. Now, to address the problem statement of my system, adding multiple cameras is imperative, in which it may provide more data to aim to increase its accuracy, precision, and more useful 3D visualization. And the need to also calculate and display a specific joint angle between frames dynamically also proved to increase its usability in terms of assessing the safety level of each pose of the subjects frame by frame, and may provide more insight to the final results of the motion capture process. Additionally, with the newly added list of joints angle, there is a potential to calculate the safety level of certain poses subject using Reba, or rapid entire body assessment method, that may be useful in an ergonomic risk assessment. Now, my system objective is to first successfully integrate multiple camera support in an existing markerless motion capture system, then calculate each joint's angle and Reba score for each frame and display them dynamically, while also providing or exporting raw data in the form of a .csv file, and to finally integrate all of that additional functionalities to an existing system, markerless motion capture system, while also improving its own usability and its user interface and user experience using dynamic programming algorithm method and many more methods, resulting in an updated system that has its own unique usability and features. Now, to achieve this, I will first draw the modules and architecture of the system and my modules for better visualization and clarity, and then add and create those modules and functionalities, then integrate them into an existing software or system named Freemocap. And Freemocap itself is an open source motion capture system in which I am allowed to do whatever I wish, and my aim to extend the functionalities. And by manipulating the inner workings of its existing modules and adding new methods and functions, processing and saving the value of the data using several algorithms and formulas, and to get the necessary data that will allow me to display the joints angle and Reba score of each frame of the recordings. Hi. So right now we're going to take a look at the system architecture and overall modules. So let's take a look at the architecture first. So in here, in my back, there is the diagram of the architecture diagram, which comprised of 4 separate entities, which is the user or the subject, the system itself, the Freemocap++, which I named my extended system, the local database or the directory, and lastly, the tool to capture the subject's movement, it is the cameras. Now, to explain it briefly, the user or the subject is basically the source of the motion. So without the user or the subjects in the frame or in the cameras, you cannot capture any motion, since there is no motion detected, right? And then the Freemocap++, the system itself, comprised of 2 separate sections, the front end and the back end. So the front end is basically the GUI, in which you can control, you can click, you can interact with, and the back end is basically all the process behind the screen, which comprises of the existing modules and the additional modules, in which I will explain later on. Next is the local database or directory. The local database directory acts as a database or storage locally, so the system is not internet-based, you don't need Wi-Fi. You just need the working computer or device. So it will store and fetch data from that storage into the system. And then lastly, the cameras. The cameras, of course, acts as a tool to capture the motion, the subject's motion, of course. Now, with all that said and done with the architecture, we'll take a look at the modules, the overall modules. So the overall modules comprises of the existing modules and the additional modules in which I added to the the existing system. So the existing modules comprise of camera calibration and synchronization, image or frame acquisition, motion tracking, 3D reconstruction module, and image or frame processing. Now those modules may or may not be accurate since there is no documentation of the existing modules, but this is what I get from my understanding of the system. And lastly, the additional modules that I added, which are the joints angle calculation, export data, the .csv file, and again the Reba posture score calculation. So all these my additional modules functions as as stated. It will calculate the joints angle, and it will export the data as a .csv file, and it will also calculate the Reba posture score of the subjects for each frame of the recordings. Now, this improved system with angle joints and Reba rapid entire body assessment calculation offers a significant advancement in terms of the ergonomics and biomechanics industry or area or fields. And by integrating this Reba calculation, the system can further enhance its utility by providing a detailed assessment of the ergonomic risks and data associated with different risks and poses relative to the user's pose. And this combination can greatly benefit fields such as sports science, physical therapy, workplace ergonomics, and even animation, since motion capture primary purposes was to animate animation, 3D animation, offering improved accuracy in movement analysis, better risk assessment, and ultimately contributing to a more performance and injury prevention. Additionally, this system also has numerous entrepreneurship opportunities across various industries in the field of sports and fitness and many more. Businesses can even create innovative training programs and equipment that optimizes athletic performance with minimizing risks of injury, especially in workplace ergonomics. Companies can provide solutions to improve worker safety and productivity by identifying and mitigating ergonomic risks. Overall, the versatility and accuracy of this technology and the system opens possibility for products and services that caters to a wide range of markets, as well as creating opportunities for innovation in the future. Now, without further ado, let me introduce you to my system. I called it Freemocap++. Now with joints angle and Reba calculation. Now, built on top of an existing motion capture software, an open source motion capture system, which is called Freemocap. This Freemocap++ is an extended version or an improved version providing more data that is related to the industries, which are the joints angle, frame by frame, and the Reba posture score calculation, frame by frame. Now, are you curious? Of course you do. Let's go to the demo, shall we? Let's explore the workings of my system. Hello everyone, welcome back to this last part of my video, which is the system demo of my FYP, final year project. Welcome to Freemocap++ system demo. This will be just a quick demo of my system since we're limited on time. I'll finish it as fast as possible and as effective as possible, so you, the audience, can understand my system. So again, welcome to Freemocap++ with Reba. So when you first start the Freemocap++, since again it is based on Freemocap, an existing open source motion capture system, you can actually Google this. They have a GitHub page and it is an open source project, so the community can contribute and adding any stuff that they like. Right, so when you start the Freemocap++, my system, you can run it through Anaconda prompt, the environment. So just type Freemocap and it will display this tab or this window, right? and it has different tabs: home, camera, data viewer, directory tab, and active recording view. So the default tab is the home tab, and as you can see, there are 3 different buttons: new recording, old recording, import videos, etc., etc. Right, pretty self-explanatory. And this tab, the cameras tab, is actually the first step to the motion capture process. So if you click detect available cameras, it will detect the available cameras and it will show a live feed through the system. So as you can see, there's me, and to do a multi-camera motion capture videos for with multiple cameras, right? You need to record the calibration videos, and to do that, you need something like this. This is a Charoko board. It is used for calibrating videos since it is based on Anipose. Anipose is a external Python motion capture library, so you can Google this, Anipose, A-N-I-Pose. So yeah, just record calibration videos, wave that board around for like 30 seconds, and you're done. As long as the camera can recognize these overlay, right? You're fine. You're good to go. And after that, you can immediately go to record motion capture videos. So after that, it will process a little bit, and it will generate a calibration file, and you can just straight ahead start motion capture recording here. So I'm currently using an existing recording to time, and I'm just gonna use this one. This is just a preview of one camera. So that's me. So as you can see, there are multiple footage, right? 001, 000, 001, and 002. I'm actually using 3 cameras, so 1 front and 2 sides, right? And after that, and to do that, just process the motion capture videos. It will process a little bit, depends on the time, the length of your recording. So the longer your recordings, the longer the process it gets. So now in the prompt, as you can see, it is currently processing right now. So I'm just going to skip this process and just straight ahead go to the finishing part, right? Right, so the process is finished. As you can see, the terminal here, right? The process is currently finished, and you can see the log here. So it's actually using CNN pack delegate for CPU and etc, etc. Right, now it's finished. We can now move on to the data viewer tab, and after process, there is not much here, right? Everything is disabled, everything is non-enabled, and to enable that or to update the value, you just need to reboot the GUI, and it will take a sec. And voila, the value is updated and everything is enabled. And if you press play, you can actually see the skeleton here, right? The lines, the 3D view, and the changing degrees or angle degrees. As you can see, it's changing based on the poses here. So as you can see, it's changing. And there's also a Reba score. So to calculate the Reba score, you just need to follow these steps, right? So enter the current session angle CSV file.path. So just locate the current session angle.path. And there's actually a guide here, usually located in here. So just locate that, copy the path, and press submit. It says file exists, and it will immediately process that. And after that, check our current conditions. This is for Reba process. Just check whatever needs to be checked, like a condition, trunk condition, upper arm, wrist, coupling score, whatever, right? Based on the current pose, of course, but you can just play around with this. And although we have processed it, again, the Reba score is still 0. And to update that, just reboot the GUI again. And it is updated. Wow. And the Reba score, the higher it gets, the more riskier it gets. So the more it gets, the more that as the risk injury, the potential risk injury, and the lower it gets, the more safer it gets, basically, right? and it will, like here, it will also increase. And another example is this pose. As you can see, like this, when holding this weight and the coupling score, the Reba score is actually 9, which is pretty bad. Has a riskier potential of injury. So yeah, just follow the steps. The Reba score is updated, submit and reload the GUI, just play around with this, and yeah, that's it. Thank you for listening to my video, and yeah, thank you and see you again.